In this lesson, you will learn how to solve square root equations. We're going to start right away with an example. 3 is equal to the square root of b minus 1. Now, the process is similar no matter what kind of equation you are solving. We will start by squaring both sides of the equation because we do need to eliminate the square root before we can go any further. So when we square both sides of the equation and then simplify, we end up with 9 is equal to b minus 1. Now we're going to add 1 to both sides of the equation, and our answer is b equal 10. But we are not finished. We must remember to check the validity of our answer by plugging it back into the original equation. If we plug 10 in for b, we find that we have the square root of 10 minus 1, which is the square root of 9, which is in fact equal to 3. So this is a valid solution. Pause now and copy down this entire example. Our next example, the square root of negative 8 minus 2a is equal to 0. Again, we need to get rid of the square root before we can do anything with what's underneath it. So we're going to square both sides of the equation, simplify, and then we will solve for a by adding 8 to both sides of the equation, and then dividing both sides of the equation by negative 2. That's going to give us a is equal to negative 4. And as always, we're going to check our answer back into the original equation just to make sure we have a valid solution. If I do that, if I substitute negative 4 for a, then I end up with negative 8 plus 8 is equal to 0. So the square root of negative 8 plus 8 is the square root of 0, which is equal to 0. So, in fact, this checks out. Our next solution example has a square root on both sides of the equation. Now, don't panic. Our process is going to be very similar. We're going to square both sides of the equation. That will cancel out the square root on both sides. Then we're going to simplify by adding k to both sides of the equation, and then adding 11 to both sides of the equation, and then dividing both sides by 4. Not negative 4, that's a typo there. And that gives us an answer of k equal 4, which, if we plug back into our original equation, we will find is a valid answer. Pause now and copy down everything for this example. Now we're going to look at 3 word problems. In the first example, we have a word problem involving how far a person can see based on how far above sea level they are. So at an altitude of h feet above the sea, the distance d in miles that a person can see an object is found using this equation. The distance d is equal to 1.2 times the square root of h, the height. And the question is, how high must a person be to see an object on a clear day? Now, in this case, you're given the equation. So, really, we take our equation and all we have to do is substitute 6 for d. So we're going to plug the value 6 in for d and then solve for h. Now, before we can square both sides of an equation like this, we have to get rid of that 1.2. The square root has to be all by itself. There can be all kinds of things under the square root, but there can be nothing outside the square root before we square both sides. So that's what we're going to do here. We're going to divide both sides by 1.2 in order to isolate that square root, and now we can square both sides of the equation and get our answer of h is equal to 25. Now, as always, we are going to plug that answer back into the original equation and make sure it checks out. So if I plug in 25 for h, I know that the square root of 25 is 5. And 5 times 1.2 is in fact 6. So this answer checks out. It is a valid answer. Pause now and copy down this entire example, including the word problem. Our second word problem, you are not given the equation. You have to come up with the equation. Now it says that the square root of the sum of some number and 6 is 5. Find the number. So, all right, now sum suggests that I'm going to be adding some unknown number, x, and 6. And I want to find the square root of x plus 6. And the is tells me I'm going to have an equal sign. So that whole thing is going to be equal to 5. This is your equation. Now once I have my equation, I solve it just like I solve any other square root equation. I'm going to square both sides, and then I'm going to simplify that. That gives me x plus 6 is equal to 25. And now I'm going to subtract 6 from both sides to solve for x, and I get x equal 19. As always, I'm going to check my answer by plugging it back into the original equation. I have the square root of 19 plus 6. That would give me the square root of 25, which is 5. So I have 5 equal to 5. That answer checks out. Pause now and copy down this entire example, including the word problem. Now that brings us to our last example. The square root of the product of a number and 4 is 3 less than the number. Find the number. Okay, now let's analyze what this is telling us. First of all, it uses the word product, which tells me that we're going to have to multiply something. And it says the product of a number. Doesn't tell me what the number is, so I think I'll make that my variable, because variables represent unknowns. So the product of my number x and 4. Oh, I'm multiplying 4 and x, so I have the square root of 4 times x is, that tells me that's where my equal sign is, 3 less than the number. Well, my number was x, and 3 less means x minus 3. So this is my equation. Now that I have my equation, I am going to have to eliminate that square root in order to solve for x. How do I do that? Well, by now you've probably figured out that you need to square both sides of the equation to cancel that out. Now I want you to note that when we square something like x minus 3, we have to FOIL. We can't just multiply x times x and negative 3 times a negative 3. That will give you a wrong answer. You have to FOIL. So if you need a review of FOIL, come to tutoring or look it up on Google. There are lots of resources about FOILing out there, but learn how to FOIL in order to do this kind of problem. When we do FOIL, we're going to end up with x squared minus 6x plus 9 on this side, and we canceled out the square root on this side, so we have 4x. Now I'm going to simplify by subtracting 4x from both sides. And now I have x squared minus 10x plus 9 is equal to 0. Well, that's just a quadratic in standard form. And it is factorable. I need to solve for x, so I'm going to use factoring to do that. Now, this is fairly straightforward. I need to find two numbers that, when you multiply them, equal positive 9, but when I add them are equal to negative 10. Those two numbers are going to end up being negative 1 and negative 9. So I'm going to use those to write my factors. But I'm not done. I need to solve for x, so I need to take each factor and set it equal to 0 and solve for x. So you see what I've done with the first factor, x minus 1 is equal to 0. I added 1 to both sides and ended up with x is equal to 1. But if I substitute 1 back into the original equation, I find that it does not work. It is not a valid solution for this equation. Those solutions are known as extraneous. However, when I solve the second factor, I get x equal 9. And if I substitute 9 back into the original equation, It, in fact, works. It is the only valid solution for this equation. So remember, it is very, very important that you do check the validity of your answer by plugging it in. Now that concludes this lesson on solving square root equations. I want you to bring your notes. First of all, make sure that you've copied down every example in this video. And note any questions that you have. I want you to bring your notes to the next class and be prepared to apply them right away in class.